Welcome to Episode 6, Interpretation of the Derivative. What does a derivative really mean? It's not just a slope or a formula. It's the story of how things change, instantly. Rate of change. The derivative tells us how fast a function is changing at a specific point. We call this the instantaneous rate of change. If f of x is a function, then f prime of x tells us the rate of change at x. For example, if f of t is position in meters, then f prime of t is velocity in meters per second. Example: position and velocity. Suppose s of t equals t squared plus 1. This tells us the position of an object over time. The derivative is 2t, so the velocity is 2t meters per second. At t equals 3, the velocity is 6 meters per second. That's the power of derivatives, they make motion exact. Tangent line interpretation. Another way to interpret a derivative is as the slope of a tangent line. At a point x equals a, the tangent line touches the curve, and its slope is f prime of a. This tells us the direction the function is heading right at that point. What the derivative tells us. The sign of the derivative tells us how the function behaves. If f prime of x is greater than 0, the function is increasing. If it's less than 0, it's decreasing. If f prime of x equals 0, the function might be flat or at a turning point. Real-world applications. Derivatives show up in real life everywhere. In physics, they tell us velocity and acceleration. In economics, they give marginal cost or marginal profit. In biology, they can describe how a population grows or declines. Anywhere something changes, derivatives describe it. Let's review. Derivatives tell us how fast things are changing, the rate of change. They give the slope of the tangent line, and they help describe motion, direction, and behavior. This is why derivatives are essential in math and science. In the next episode, we'll learn shortcut rules for computing derivatives quickly. We'll cover the power rule and the sum and difference rules. Let's speed up your differentiation game. See you there.